I'm going to talk a little bit about the lessons from the backend. We've been doing a project here for the past year, and that's actually live. So we're actually using this stuff. I'm not going to talk about a lot of the fancy stuff, or at least I think it's not the fancy stuff, because I'm going to talk about what we actually use and what we actually enjoy from the language itself. As has been said, I'm CTO of machine learning, although this has nothing to do with that, but I just really like the language and I wanted to share this with you. So like I said, features we use. So a little bit about the basics. Maybe a good show of hands would be how many are using Kotlin live in an actual application. Okay, those are many people. So I will do this slide by slide. If people are not interested in seeing examples of basic stuff, then we'll move on. Otherwise, I have examples of basic stuff. Good. So I'll talk a little bit about integration with frameworks, Spring, Jackson, Mockito, and then discuss some of the things that we sort of struggled with, or not really struggled, but sort of had a first struggle with and then won. Oh yeah, before I say PHP, so I have a background in PHP. No, I wanted to show you this. This is the way I got introduced into Kotlin. Indeed, somebody got that right. That's what I wanted to say. By applying this to an internal application that I made for myself, and that was initially built in PHP. Okay, so I chose PHP at that point because that's what I learned to do when I was 15 or something like that. So fine, it was very fast to make software. It's very simple, you know. It's very nice to do these kinds of things. But at some point you hit the wall, and you gladly change in that speed and simplicity for scale and the assurance of a strongly typed thing, and that really makes you happy at that point because you just want the thing to work. But then, in I think October, November 2016, I ran into this Kotlin thing, and I decided to do to check it out, basically. And I got simplicity back, less code. I always love less code, and I got functional stuff back. I worked on 8 months. I worked on Scala. And that had a lot of functional stuff in it, but we couldn't really make that work in a simple way. So it's nice that we could have that mix here. So that was my own introduction, and then when last year in May we started a new project for a major client, I said, why don't we do this in this stuff? Because that's really interesting to do. Let's make this happen. This is going to be hot, and you guys here show that. So, major clients, they needed to move away, of course, from an existing monolith. Most clients do, and we needed to replace a part of that. So that's what we did. Started in May, like I said. Spring Boot 2 by now. Hibernate, Redis, Gradle. Initial Java, but pretty soon moved to the Kotlin stuff. So, oh yeah, this is going to be lessons from front end. So this is lesson 1. It's cool. So for those that are already using Kotlin, it's pretty obvious. But I guess some of the others want to have some ammunition to tell your team why they should really start to learn this stuff. So I'm here to help you out. So, first of all, why do I want to Kotlin? I don't like to type or read fluff. I want to get to the point. Kotlin allows me to do this. I'd like to understand the errors that I cause. I make faults. I'm a man. I make faults. Women never make faults. So I like to understand why that is. I love up-to-date documentation. Everybody does. I'm really into predictable and relevant APIs, and people pick this up very easily. So that's, I think, pretty good. Then there's, of course, a bunch of other reasons. So I put them all in word cloud with animation. Awesome. Anyway, so lots of reasons. So now let's get to the code. And this may be the basic stuff, so I'm going to just browse and see what I need to get into deeper, because I also talk to people that haven't used Kotlin as much, so yeah, I want to strike a nice balance in it. So I'm going to talk about these subjects, very basic stuff first, implicit types, no more specifying the type when you declare something. Null-safety is a feature that we have a lot of fun with. The methods that we can do on lists, so the functional programming part of that, and something about extensions and type aliases. That's basically what this talk is about in terms of the basic Kotlin stuff. So first of all, implicit types, very simple. We get to define a function, looks like this. It's a function that turns a string into another string, so we can call that with my ever creative blah example string, which you will see a lot more of, I think. And then if I juxtapose it to Java, then we get a little bit longer piece of code, but we still sort of like this new syntax that Java introduced. Although I don't like apply. I don't know why it has to say apply here. I never asked for that. I don't care about apply. But okay, that's fine. No good reason yet. So now I want to do a function that has a little bit more arguments, because I write software and that has functions with multiple arguments. I stutter as well, so sometimes it's really, really exciting what's going to happen next. Again, I did it. Yeah, but sadly that sort of looks nice in Kotlin, and then in Java it's bit of sad story, but there's two ways to be sad. There's one where you sort of nest these functions, so then it looks like you're doing something that's nice. So that's cool. And then you get to apply some more, so that's nice. Of course, this isn't going to be a Java bashing evening, but I cannot resist. The other thing is where you have to determine a separate interface that sort of gives you what you want, and then you can use that, and that says, sing. Yeah, that sort of gets closer to where I want to be, although I don't want to be there. And I still get the one apply. Does anybody want to see an example of this stuff? Yeah, okay, good. Let's look at that. Is this visible for everyone? Yeah? Oh yeah, so it's a very stupid and simple example, but we can run it at least. And then it's too big for the thing. But, so, okay, that's interesting. So it generates a function, or it generates a string. Oh yeah, right, I call this string. Oh, that's stupid. That should have been blah, right? I don't like that. Make that obvious. So there you go. So it's very, very basic stuff. We can define a function without it being the member of a class or anything, just an inline thing, and then just use that. So far, so simple, I would say. If there's questions, and I'm looking at my screen a lot, please just shout out and say, "Hey, but wait," this sort of thing. And then, of course, the Java equivalent is this is like I showed on the slide. It's a little bit more involved. Okay, good. Let's look at something else. Null-safety. So one of the sort of billion-dollar mistakes is that, as it has been dubbed, is the introduction of null, because of all the faults that are made, and then we still try to deal with this stuff. And Kotlin does this, I think, in a really nice way, in principle. Basically, you say in a very short way, you say, well, this could be a string. It could also not be a string. In this case, I'm being really explicit that it's not a string, but that could have been a var, or it could have been something that comes out of a function, and that could have been not that obvious. And then we have a way to say, well, let's get a default value. So here what you also see is that an if statement actually returns a value. So you can use that as an inline thing, as a replacement for the ternary operator. So here we say if it's null, then give me anonymous, otherwise use that string. And what's nice about Kotlin as well is that it does a smart cast, so that maybe string outside of this else block was a string that might be a null, but in here it's going to be an actual string, like a hard string, because we know that we've already checked whether the question mark was there, and if that's not the case, then we know that this is going to be an actual string. So that's really nice. But we could make that a little shorter by using the Elvis operator, which is nice, and then yeah, that becomes a nice small thing. So far so good. I really like it. Save calls. Here we can sort of chain the calls that we would want to do on an object, in this case this string, but do it on the precondition that it's not null. So here we would say get me the length of the string if that string is not null. Okay, fine. Do we want an example of that? Sure, less enthusiasm already. Okay, that's good, that's good. No, that's fine, that's fine. I just spent hours on this stuff, man. No, okay. Is there anything else that I showed on the slide? Yes, a little bit. I didn't show this part where you say, well, I know that it might be null, but in this case, I'm really certain that it's not going to be null. There's just, you know, I just know that it's not going to be null. Ideally, you wouldn't have much of this in your code, but in the end, you're using frameworks that don't really know about this stuff, and then you'll see that you're using this more than you would like. But it's, yeah, I mean, it works. So yeah, that's it. Good. Next. I'm so happy I brought the clicker because I'm never at the keyboard. Oh yeah, I have a question, I guess. So there's one thing that I like about Java, or for that matter, another language that also does the optional thing, class, and that is that I can map over the optional, which more often than not I would like to do. Because what is mapping over an optional other than just a generalized form of this final case right here? Here I'm saying, if I have a string, I want the length field. Okay, fine. But maybe I would like to do an arbitrary operation once that string is an actual string. And Java gives me that. I can make an optional, which is, you know, sort of the equivalent of that question mark thing. And then I can do map on that stuff. So that means that if this were an actual string, that would become value plus that string. But if it were null, it would, or if it was an empty optional or null in this case, that would just leave that be. So I would like to see this. However, this does not work. Which basically says, well, we have our favorite string here again, and then we say, well, if that is there, do this operation with it, and then the it variable is the default that you use within these operations. However, it's got the crossed fingers there. It's not in. Maybe in a future version of this.
You can do let.
Let.
Yeah, let checks for null, and then if it's not null, it executes that box with the.
Okay, cool. Thanks. I guess I made a mistake. Okay, cool. I'll look that up. Oh yeah, so now then that point doesn't matter. I've got, yeah. Moving on. Okay, functionals. Just for everyone who isn't aware of functional programming, I didn't put a full list of what sort of I mean by that, but these are three of the most common functions. How many of you don't do functional programming? Cool. Well, for you four guys, I've made this slide. So it's really, really simple. Map turns a list of something into a list of something else. Flat map turns a list of lists, which more often than you would expect actually happens in code, into a list of something else, which is really nice. And then group by does the group by as you would expect it from SQL or whatever you have, which turns a list into X into a map of something else and pointing to a list of things that have the same y, so to say. Then that looks like this, which is slightly bigger. Let's do this. So here what I created is a short transformation function. It takes a list of these report object on the top there. In this case it's only one, but I was lazy. And it turns that into an object that holds the average of the scores that are included in the original objects, and a list of some things called score records. Now, which is really nice is the average is pretty easy to get. You just do you just make sure that the score that you're talking about is not null. And by that time, you're certain that that score that used to be a nullable int is an actual int, and then you can have the average of that. Then you group by, which again sort of speaks for itself there, and IntelliJ is nice enough to sort of show us what then that type would be. And we flat map over that stuff, turning a list, which is the list of reports, into a list of the score records. That is what we want. And then by flat map we get one list that holds all of these things all together. And then finally we have a sort of a check that says, well, if that reports thing used to be empty or was actually empty, then never mind, give me nothing, and otherwise give me this new thing. Okay, so that's good. So how does it look in Java? Less great. So you've got sort of the same thing. I have to get it a little bit out of the way, but the average becomes a wonderful dance of stream, weird collector stuff, averaging double, then get the double value for the. It's just a very hard to read bunch of stuff. Then here there's a for each that generates that value and collecting a grouped thing. It's, to me, I know what I like better. And in fact, if I look at the actual code, this actually turns into very hard to read stuff. Just very hard to read. All right, I'm hearing sighs, so I'm moving on. Kotlin has it's fine, it's been a long day. So Kotlin has a bias towards immutability. So that's and that's actually something that I really like in my local variables and in my fields, that I can say, well, this is actually a val in Kotlin terms, and we don't want that to be changed ever again. So that's really nice, and it's a nice shortcut. They have the val for the things that may not change, and the var for the things that may. And for classes, they did a little bit of a different thing. They just said, well, the default thing is final. So when you declare a class, you automatically get a final class. And only when you explicitly say this is open, then you get a class that may be extended, which I will come back to. But it's important to keep this in mind that is there. Another nice feature of Kotlin that we use, not that much, but it's still nice to show, is the extensions feature, where you can say, well, actually put this method on anything that is of a certain type. Much akin to what you can do in JavaScript as well. You can just extend the API of a standard object in this way, or an object that is final or something like that. In this case, I wanted a random range of a certain list, so I could just say, well, add that to the list interface. Another thing which is nice here is that you get this operator that will give you a range with an infix function, which is more to the DSL side of things, but still a nice feature to be aware of as well. Type aliases are really useful for sort of abstracting the complexity in your data structures. I showed that Java function sort of signature. It would be really handy for that stuff. Now we cannot use it in Java, so that doesn't go. But for all the other cases within Kotlin itself, it's really, really handy to have. Where you can say, well, if I talk about a file table, then actually really what I'm talking about is a mutable map of things, and then I can use that in assignment. Now, it's actually not that useful in this example, but what we found it to be really useful at is when we're passing around these sorts of objects from one method into another, but we're not really doing anything, we're just passing it in to the next. Then it's really handy to have a shortcut so you don't have this signature of this object all over the place. That was a good one. Secondly, you can also do that with functions, where it looks like you have a class now, but it's really just an anonymous function that says I'm turning the string into something else, whatever it may be, and then we can actually use that in that way. It's a really nice one as well. I think type aliases is just that. It does that, so it just yeah. Okay, that's that I think covers it. Okay, good. So that was lesson 1. It's cool. Any questions so far?
Oh yeah, actually I'm quite new to the language, so I was wondering the calibrated syntax that you're using here last time.
Yeah. This one?
Yeah.
You mean this on the bottom line? Yeah. What do you want to know about it, or just observing that it's new?
So this is quite new to me.
Yeah.
So I have no idea what that does.
Okay. Well, you've got the type of the function, which is this. So this basically says this is the signature of what you're going to create, which says I take a string and I generate a key. Yes, I get it. Yeah. I was going there. I was going from you know. And then the assignment says, well, if I want something of that type, which is in the end what this thing is saying, or at least it's an int, then I want to declare that. So this is the declaration of that function itself. In this case, a curly bracket saying, you know, give me a string and I will give you the length of that string.
But you have only S there, not string? Like S, not S string?
You mean, could you take this out?
Yeah.
I actually, I tried that and I think you can't, although I would expect that you would be able to. But if somebody's smarter than me, please let me know that I'm wrong. But I would expect indeed that you would be able to take this out, because it would be able to find that type by going through the declaration and sort of seeing, that must be a string. But you know, let's try it out. Oh, sorry, you're completely right. Yeah, that's not helping. That maybe mean.
Right.
Yeah, exactly. Then we can do this. So it becomes even more short. Yeah, you're absolutely right. I think I tried to remove it there or something. I must have been doing the same thing. That's stupid. But yeah, indeed. So then it becomes even more interesting, where it says, okay, we can take this shortcut, because if this is if we don't want to give that an explicit name, then we have the default name of it. So we don't have to do any of the, I'm getting this and now I want to do that with it. No, it's just going to be, I want to do that. And that's basically what that does. Cool stuff. Okay. Right, so that was lesson 1. And any other questions? All super clear, good. Let's get the one about implementing Kotlin into your project. There is, I made a funny slide. I remember now, it's with the Simpsons. I haven't decided how to do this yet. So this you're going to be the big experimental group. So this is Homer talking, right? Homer decided to change. You need a little bit of story here. Homer at some point decided to change his name into Max Power. Don't know why he did it. Well, that's a part of the story as well. But let's not go into the details. And now he's telling his kids what it's like to be that man. So he says, kids, there are 3 ways of doing things: the right way, the wrong way, and the max power way. Okay, cool. So Bart asks, isn't that the wrong way? And Homer says, yes, but faster. So let's talk about ways to make this change. Good. So the first one is, woohoo, do everything in Kotlin. Just throw out all that Java stuff. It's all way too much and it's annoying, and just make it all nice and clean stuff. Get it to me. Provided that you're not a super guru at Kotlin yet and you've got some experience in Java, this is probably a pretty bad idea. So I would call that the max power way of doing things. Although this isn't the wrong way faster, I must admit, but still this is pretty shoddy. The other one is to say, well, I really like this Kotlin stuff. It's really short and nice, and I can do DTOs in this very nice data class way, and woo. Let's use it only for the tests. I don't really get that. To me, that's also, hey, that's strange. No, I'm kidding. It's also wrong on my side. But yeah, so that's also the wrong way, because then you're losing out on a lot more fun that you would be having if you were to just use it everywhere. But then using it everywhere shouldn't be done all in one big blow, but doing it step by step. So what did the team say when I said when they sort of joined and they said, well, okay, we apparently are doing this thing. So initially, somebody said, who is here right now, maybe they can do it, what is this shit, right? Because I'm used to Java. What is this crap about var and val? Is this JavaScript or something? And then pretty soon, they get to the realization that it actually works really, really well. It's a very intuitive way. What I found is that apart from setting up the initial application and doing the sort of the hard parts of making sure the framework works, sort of the little nooks and crannies, apart from that, it went really, really smoothly in terms of a team that wasn't used to the language at all, applying it and using it and finding it really, really nice, to the point where they rejoined another Java thing and actually said, I'd rather do the Kotlin thing instead, but that's life. So that's really, really good. However, you cannot have this unless you do this in a smart way, because you don't want to be the guy that has to tell the client, yeah, we spent a week trying to figure out how this flat map thing works, and yeah, vol and var, there's something wrong there, but I don't know what. Luckily, it never happened, because we did it step by step. We did the small stuff first, the simple stuff, and then we incrementally took over the other classes as well. But don't be the team that sort of ends up with some class in Java and some in Kotlin, because then you're losing out on a lot of the simplicity that you would be having. Because then you still have to keep in your mind, oh yeah, this is the way it's going to work in Java, and how does that work with the getters and the setters and all that stuff. Just make sure that you're on a slow and steady road towards just a pure Kotlin application. That was lesson 2. Any questions about this? Yeah?
How do you introduce Kotlin in a team if a team is working on a single project and it's already Java?
Yeah. So the question is, how do you introduce Kotlin on a team that is already working on a big Java project, basically? I think there's a number of ways to do this. The nice thing about Kotlin is that it's not you don't have to do it all in Kotlin. So one of the sub-steps might be to take, for instance, the tests. Say, well, let me do a test. Let me create this test suite in Kotlin and see how far we can take this. But if you want to get people really riled up and enthusiastic, let them do this on their own. Have a session where you start saying, well, what if we could create this part of the application again, and then using this new thing, and then people actually get their hands on it instead of this guy that does the new and hot stuff. It becomes a thing that's owned by the entire team that says, hey, we really like this stuff. We would like to do this as a team, learn this stuff and move towards this new thing. So I think those are the things that you could look at. Does that sort of answer your question? Okay. Yeah, you?
In your experience, how long does it take for developers new to Kotlin to reach kind of the speed similar to what they had in Java, or at least to be productive member of the team?
Productive member happens within 2 or 3 days, I would say. The change, and then I'm talking about making changes on existing code. That is due to a very intuitive API. You have a list, you would like to do something with that list, and that API is likely to have been written already, so you don't have to work around the API, you just use the API. So that's very, very nice. To actually master this stuff, there are a few sort of, like I said, nooks and crannies where the mix of Kotlin with an existing framework will give you some sort of headaches where you need some experience and need some time to figure out how you should do this stuff. So yeah, that's the way that I would describe it. I would say with the team members that I've discussed this, and I don't see a very steep learning curve as well, because the interoperability is good. So if somebody says something like, I want this list to be of type array list, for example, which isn't a thing that you would need to do, it would still accept it. It would still say, yeah, sure, fine, I'll make this an array list. But it'll just say, fine, I'll turn it into my own little Kotlin list and move on. So in that respect, it's very forgiving in its syntax as well. And then, of course, you need to have in mind that you sometimes clean it up and say, well, where do we get a lot of Java util things? Let's clean that stuff out because we don't need it. Yeah, so that's the way it would go. Answer your question? Another question there in the back? Yeah? I didn't, and I'm going to talk about it in a minute. We basically used JUnit for it. Any other questions? Okay, cool. So here I get to talk about sort of the problems that can be counted on one hand. In other words, there are very few problems and far and wide in between. So first of all, you get the interoperability with Java. Very simple example of this is, let's look at collections transformer again. This code has more lines than the Kotlin one, while the Kotlin one actually also has the classes of the objects that we're working on, and the Java one actually uses that. So it gets a report, which isn't the Java class. It's just a class that we declared here, and then we get our steady getters and setters and all that stuff, just out of the box, which is again very, very nice if you're gonna be building a part of this in Kotlin. You're going to be able to use that in Java and the other way around as well. Next to that, I already talked about the lists and the array lists and stuff like that. Next to that is when in Java you declare a string that turns into a string that may be null. So here you find some clashes with frameworks where you're saying, well, this is going to be a string, but it turns into a string that may be null, and now you have to deal with all these things that may be null while you're really certain that they're not null. So yeah, let's look at a little bit of Jackson because it underpins the REST stuff that Spring does, and I think it's a nice way to sort of start simply, which the length of this code wouldn't reveal. Okay, so what I did is a very simple mapper, just a few examples of this thing. Let me run it. Yes, so I have a class that I would like to read. I would do it like this, basically passing in a type parameter saying, well, this is supposed to be an instance of this type, and then passing in a JSON string. What I did is I added a couple of interesting things here. First of all, I made a data class, which is a shorthand way to declare a class. You immediately you only have to write this part basically, and that just declares the entire thing from setters to getters to all the things. What is then interesting to see is that we can have an ID that has to be there, but the description need not. So if we skip that, it becomes null. And the same thing goes for the fancy code, and the is awesome actually does need to be there. We also see that we're getting default values, which doesn't make me super happy. For instance, for the false and for the 0, but that's I guess what we get. I'll get back to that in a minute. What is nice here is that we can override the not to my liking feature of removing the is prefix from JSON objects, so we can just pass in an actual thing that actually matches the field that we want to fill, which I like better than the other way. So then we have to do this sort of new to me annotation that allows us to manipulate how the value is set. So that's one. The second thing is very nice. It's a deserializer for, in this case, a sort of a magically formatted string, which I would like to have inside of an object. So here I create a deserializer that goes into the JSON node tree and sort of gets that string if it's there and otherwise doesn't. What is nice here to see, or what is interesting here to see, is that we have here an annotation that indicates that we're doing an overload on a Java class for the constructor here. What's also nice to see is that we immediately can pass the value that we got here immediately into there, where in Java you would do a constructor which then calls super, etc., etc. Here we can just have that within that one line saying, well, this maps directly to that argument on the class that we're extending, which I think is a nice feature as well. Any questions about this? None yet? Yeah, I don't have any questions prepared. So either you're going to have to eat the chocolate on your own, or if you have any questions, you can pass it to the room. Okay, sorry. I should have told you. Okay, so that's Jackson.
Sorry, one question still.
Yes.
The asterisks in the class.
Yeah.
I never put a spot a rule when I can apply it and when not.
That is a good question, and I don't have an answer for you for that.
The wildcard in Java.
Yeah.
It's like the wildcard in Java.
Nothing more. Just like that.
Yeah.
How does it differ from any? Is that a what? Can anybody indicate the difference between that? There's also an any sort of root
Like
object.
any question mark out.
Right. Okay.
So it can be null and it can be also, yeah. You can also only track stuff and not put in.
Okay. Okay. So it's really beyond that. It doesn't need to be anything basically.
It's like Kotlin doesn't allow you to have raw types like without declaring, so if you don't know the type, or it doesn't matter, you just need to define it as
Okay. Okay. Cool. That's cool. I didn't dive into that yet. All right. Next is classes are final by default, which is absolutely great when you're not using any frameworks, because then you get exactly what you want. You want everything to be final and fixed unless you open it up. You know, this is the new way of doing things, and we really love it. I love it for values, but for classes, it's sort of annoying, because we used to not know, which was nice. Spring would do all kinds of magic stuff, extending our classes and wrapping it around things, and I used to not be really aware of that, and now we have to do that, because it turns out that any of the classes that are annotated with this stuff actually need to be open, because they will be extended at runtime. So we can do this in two ways. We can either go through our code and add the open word for all the things that we know Spring will extend, or we centralize that knowledge and use the Kotlin all open plugin, for which you see the Gradle syntax, and sort of add a list of annotations for which we want the class and the methods to be fully open, which is nice. I can show the Gradle file, but it doesn't show anything more than this, so I'll forgo that. Any questions or observations about this? Excellent. Then I guess the knowledge is centralized, which would be nice indeed. That's good. So about the interoperability with frameworks, so like I already mentioned, a bunch of these frameworks will say, well, this returns a string in Java, and that then turns into a string which may be null in Kotlin, which is really annoying for stuff for which you just know that it's going to be a string, and if it's not a string, then just give me an error. I don't want to deal with this stuff. Luckily, with Spring Boot 2, they added a lot of annotations saying specifically this is never going to be null. So that's really a useful development for Kotlin, to the point where Spring actively talks about, yeah, this is an optimization for Kotlin, and this is how you use it. So next to the Android stack, now also Spring actively looks at this language as a serious option. Let's look a little bit at the REST controller there. Yeah, time. Cool. That is ridiculous. So what I did here is I wanted to go pretty deep into this, which basically in the end is the argument against using data classes, but it may be due to my lack of understanding, so I would really like to. I basically made three alternative ways of reading a JSON object and actually sponsoring it back into whomever sent it. And the sort of the most long way is the only way that actually gives me what I want. But it's also a bit weird because I annotate a field to not be null, and then I say, yeah, that thing may be null, which sucks to me. But it's the only thing that actually works. It actually gives me an error when I send ID that is null. It actually says this is wrong, etc., etc. Let's see if I've got that thing open. 5 minutes. That's depressing. So let's look at that. So I remove the ID from the call, and I get a wonderful in 17-fold error that says, somebody give me a handle. Can't get the handle. There it is, just above the line, of course. So I give a I get a huge amount of information that tells me this one field is missing, which is I guess what I wanted, or I should do something with this exception on the back end that makes it shorter. But if I use any of the other methods, I get again my dreaded 0 default for missing stuff, and then I try it another way, I get the same thing. So not super happy about that. Does anybody have any experience with that and sort of did this in a nicer way that they solved this? Sorry? I want to get an error when I pass in null for an ID or missing have the field missing. And I would like to say this. And in fact, I would like to also say this. This is going to be set only once. So I don't want this. I want to see this. Doesn't work, but I would be seeing this because this thing is sent and I don't want to change. I don't want anybody to change this thing because this is what the client said. I don't want anybody to operate on it. I want to have that very, very, very tight to my mitts. In fact, this should be enough, right? The add not null is not even necessary, but let's suppose that I'm sort of flexible, fine. But that should really not be there. So that's what I would like to achieve.
I'm not sure, but maybe
That's on vars, and that's that doesn't do well for ints, I think. There was an issue with that stuff. Yeah, it's going to say that it's not allowed on primitive types. So then what I then would do is I would have a bunch of these fields that would be that, but then the ints wouldn't be that, which is also making my face go all frowny and stuff. So yeah, I remember something about 5 minutes. So unless somebody now says, oh, you wanted to do that, that's easy. Just use let. No? Okay.
Kotlin serialization being developed by JetBrains.
Mm-hmm.
X serialization.
Mm-hmm.
Does the JSON formatting for you, I think it does this kind of thing.
Okay.
Yeah,
Yeah, cool. Thanks. Excellent. So that was some time ago, no, those 5 minutes. Let's go. Oh yeah, about the tests. I don't want you guys to miss out on that, and neither would Adele, right? Transformer test. So very, very, very simple. The most basic form of test is just the thing that, oh yeah, I have to show you the transformer class that transforms a string and does basically what the anonymous function did in the past. I just want to make it simple but have a class around it. So it turns a string into an int, fine. And the test then says, well, assert that that transformer is actually a thing. The only thing that's sort of annoying and interesting here is that because this is a keyword, we have to do the backticks thing, which is annoying, but you know, we'll get used to that, I guess. Then we have something that does sort of a dependency injection. So it says, well, this is a service and it gets a transformer. I don't know what the transformer is, but when I get it, I'm going to call that transform on a transformer from my transform function, etc. Something about transformers. So how do we deal with that? We make a mock. Now we again get the backticks for when, because there's also a when thing, and we get now sort of a little bit of a nastiness, which is a framework issue that we have to pass in the Java flavor of the class now. Okay, well, there are ways and means to get around that, but it basically ends up making a function that does that for you. And again, the is and etc. We can mock that stuff. What is interesting to see is that that class then has to be open. For Mockito to work, it needs to be able to extend that class. So, and let me see, that's sort of that. Yeah, I can show you what all the stuff that happens when you don't do that. There is an example of a closed class that fails, an open class with a closed method that fails, and then something that's open that actually works.
You can use Mockito inline, and it will open all the closed classes for you.
Yes, sir?
You can use Mockito inline.
Inline.
Yeah, there's another dependency instead
Okay.
of regular Mockito, and you wouldn't need to open classes.
And it's instead of the standard Mockito.
Yeah. And
Okay.
there's also Kotlin Mockito, which
Yeah.
is
Yeah, by N. Harman or something like that, right? Yeah. Yeah, I'm using that one as well. But then that doesn't open your classes, I think.
no, it's
That just
two
gives,
separate things.
yeah, yeah. Excellent. Good point. Thanks. Any other question? Yes.
Can Mockito 2 just do that? You can work with private classes or maybe JMock it, maybe with static classes as well.
What's your exact question?
Well, you said you have to make everything open, but if you use different framework, so Mockito 2 is
Yes.
you don't need to do that, right?
That may be true. By the time I tried Mockito 2, it didn't interoperate well, or it was an experimental feature that did the class extension in that. I don't know if it's stabilized now, but
I've been using JMock it for the last year,
okay.
and yeah, so just incremental open.
Okay. Oh, that's good. That's a great one as well. Thank you for that. Great. Okay. We are probably in the negative on the amount of minutes left, so let's go on. Oh yeah, future lessons. So I'm almost there. That's good. So the fancy stuff we haven't used yet. So we didn't use the coroutines. I heard one or two people be really excited about that. We don't use lazy evaluation yet, although it's a pretty nice feature. And there's an example which I would show you. We don't use the Kotlin DSL instead of the Gradle standard one. I looked into it shortly, but then I ran into API troubles, and I was like, Gradle still has some issues. We don't use DSLs in general, and we haven't looked at Kotlin native or any other of that. Other language stuff, so not on the client side, not on the JavaScript side either. Concluding thoughts, yeah, it's 3 lessons. I hope that's come across, so it's cool. I really like it. I really enjoy that it's so easy to learn. But if you do this, do it step by step. Really have the advantage of using Java and Kotlin next to each other for some time at least, to make sure that you're not inside of a new world where you're like, yeah, I used to be a really good Java developer and now I suck at this, so sorry client, you have to wait for 3 weeks before I figure this stuff out. Don't be at that point. That's not good. But the problems that you will hit are really minor or really limited in number. So yeah, that's it. Good.